right, write this down. These will be good examples to have on hand. I promise there are problems on these topics on the exam. I made it myself as a Word document. It will be in forms. You will get a link to the form. It will be posted probably in your digital sessions on CTLS. And if you don't see the link when it is your time to do the exam, just shoot me an email. I'll send it over.
When the exam is?
I'm sorry?
When is the exam?
Your exam is on Friday, but I'll open it up on Thursday at 11:30.
So I can take it on Thursday?
Yeah. You should have a 24-hour window to complete it.
No, because I gotta, I'm not gonna be here Friday.
You won't be on campus at all on Thursday or Friday. You'll be absent on Friday. You got things to do? You have.
I got a basketball tournament in Tennessee.
Okay. Well, yeah, you'll have to get it done on Thursday. Okay. Here we go. So I'm going to do a little bit of what we talked about on Friday in case you were absent or sleeping or whatever it is that you do. That's not math. All right. So we talked about finding these different characteristics, the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote. Each piece of information comes from a different location on the function. The x-intercept comes from the top of the fraction. You set it equal to 0 and you solve. The x-intercept will be written as an ordered pair. So I get 3 as an answer, but it's going to be 3, 0. Sorry, that's a wonky 3. That one wasn't much better. Sorry. X equals 3. So the ordered pair is 3, 0. The y-intercept comes from plugging in 0 for both of the x's. So 2 times 0 minus 6 over 3 times 0 minus 1. So that would become 2 times 0 is 0. 0 minus 6 is negative 6. 3 times 0 is 0. Minus 1 would be negative 1. Negative 6 divided by negative 1 is a positive 6. But we would write it as an ordered pair. You plugged in 0 for x. You get out 6 for the y. It's an ordered pair. Y-intercepts and x-intercepts, they're dots. That's why you write them as ordered pairs. The vertical asymptote comes from solving the bottom of the fraction. X equals, this would be 1/3. it is an equation of a line, the vertical asymptote goes up and down on the graph. The horizontal asymptote is a fraction of the front numbers. So this one would be y equals 2/3. And a horizontal asymptote is a dashed line that goes left and right. Carl, bring me your phone.
I was writing it down.
You're staring at your phone. Strike one. Alright. The next thing that we discussed on Friday were the different transformations for a square root function. And there are 3 that we saw in that unit. If there's a negative in front, it causes a reflection across the x-axis. If anything is added or subtracted to x, it shifts it plus to the left, minus to the right. Anything on the outside shifts it up or down. And that left, right, up, down is exactly what we saw with exponential functions, so don't forget that. So those are all the things that we talked about and practiced on Friday. So to move on and talk to you about other things that we saw this semester, we're going to start talking about solving some equations. What?
You put that like in the screen for like a second.
Yeah. This part?
Yeah.
Sure. All right. So we're going to talk about solving. We're going to start with solving radical equations. No, I just keep going. What you mumbling about?
I don't know. I'm thinking of writing these notes.
You too old to be acting a fool. Take your jacket off. Okay. Jamal wants you to take off all your clothes.
Oh, yeah. Oh, yeah.
I'm dead.
And I gotta say this picture of your mom.
You're gay, and there's no picture.
I'm recording.
Now they're gonna have this on replay.
This is how I'm going to get YouTube famous. All right, so you have to isolate the square root, which means we're going to subtract 1 over to the other side. After we do that, we're going to square both sides. So I'm going to square this, and I'm squared this. What are they watching?
I don't know, they watched your board.
Oh.
The hockey thing.
Uh-huh.
I don't know what they're watching. This class might actually get their idea of what to watch.
Oh, okay.
First class just
Said nothing. All right, so what that does on this left side, the exponent cancels the square root, giving us 5x plus 14. And make sure, this is not 6. What this means is there are 2 3s sitting there. 3 times 3 would be 9. So don't make that mistake. Now you're ready to solve the equation. Subtract 14. Divide by 5. All right, so I'm going to throw another one like this at you, but I'm going to change it ever so slightly. So what's different about this one is I'm using the cubed root. It's already isolated though, so I can go ahead to the second part. And instead of squaring both sides, we're going to cube both sides. So I'll use a little 3 right here. And use a little 3 right there. The cubing on this side cancels the root, giving me x minus 5. On this side, this is not going to be 6. This is 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 more is actually 8. Now we're ready to solve the equation. Eight, 9, 10, 11, 12, 13. Easy peasy. So I'm going to switch gears from the radical equations, and we're going to hit up those exponential equations. We should be getting a little bit closer to things that you sort of remember doing recently. You should recall that we made a chart in your notes for these types of problems. So 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32, and so on and so on. We will not recreate all this right here.
Hi,
Hi.
where's Miss Cannon?
Miss Cannon, the math teacher, upstairs, like she's not directly above Miss Williams' classroom, but she's the next one on the right.
Okay, thank you.
Mhm.
I was looking and I didn't.
Yeah. All right, but this is kind of what the chart looks like in your notebook. I don't look crazy there. You should have it somewhere, I hope. All right, but what we did in this section is we would rewrite the bases to be the same. And you always tried to make a bigger base look like a smaller one. You couldn't make a smaller one appear bigger. You could only squeeze the bigger one into a smaller size. So I would rewrite 32 as 2 to the 5th power. But I have to keep everything else the way it was. There was an x plus 5 here, and then there's a 2 with an x plus 5 over here. Once I got those bases the same, I didn't need them anymore, and I could set the exponents equal to each other, so I could solve. Another style of problem we saw in this section was solving logarithmic equations. And to solve a logarithmic equation, we had to rewrite it as an exponential. So we use this loop. We started here at the base. 4 to the third equals x. So to finish solving, all you needed to do is figure out what 4 times 4 times 4 is. And it happens to be 64. All right, the last topic I want to discuss are the word problems with formulas that we saw in this unit. A equals P times 1 plus R. A equals P times 1 minus R. A equals P times 1 plus R over N to the NT. And A equals P E R T. T. Mm-hmm. All right, so P is always the initial amount. Initial. I-T-I-A-L. Sorry, I kind of spelled that wrong. Initial amount. R is the percent as a decimal. You're going to need to divide by 100 there. T is time. You use this formula when they talk about compounding. You use this formula when they say compounding continuously. Carl, what do you need? Why are you staring at her? Are you telling me my eyes deceive me, sir? She probably can't because you a mumbler. What do you need? Okay. I'd like to show you two of these examples if we can squeeze it in before lunch. so 3,000 is gonna be P. 9%, I'm gonna take 9 and divide it by 100, which is 0.09. Compounded continuously tells me I'm going to use the formula with the E in it. And 6 is going to be my T. So the final amount equals 3,000 times E to the 0.09 times 6. E is a button on your calculator. It is not a variable. So you would make $5,148.20. Well, you wouldn't make that much, but you'd make over $2,000 on that investment. Banks don't really pay that much interest, but in case they did, it'd be worth your time. All right, I'd like to try to squeeze in one more before we run to lunch. Purchased. Y'all go to lunch.
Right now?
Yeah. Zoomers, I'm going to finish this problem with you guys and I'll talk to them about it when they get back from lunch. So they purchased a car. The fact that it depreciates means it's losing value. So I'm going to use that one with a minus sign.
I'll listen to you.
Thank you. Appreciate it. All right, depreciates 7.5% is our rate, but I do need to take that 7.5 and divide it by 100, making it 0.075. And then there's my year's T. So I would say 17899 times 1 minus 0.075 to the 10th power. Which would be $8,208, and I would round that to 17 because the number to the right of the 6 is a 5. So even 10 years later, it's still worth about $8 grand, which is not bad. All right, guys, so that's the review for today. I hope that you do your Delta Math assignment and practice for the final exam. If you have questions, just shoot me an email.